Hey y'all, welcome back to AP Stats. I hope you all had a wonderful weekend and was able to rest up and re-energize. For those of you that have started AP testing, best of luck. You all can do this. You've been working so hard all year long, and you're just going to do amazing on all of your AP exams. So for us, our AP exam is May 22nd at 11 a.m. It's online, it's all FRQ, and you are getting 45 minutes to complete the FRQ. Um, for us, the we're going to be having a virtual boot camp for stats for us to review as many problems as we can on May 16th. So that's Saturday, May 16th. It's a Saturday coming up from 2 p.m. to 4 p.m. I've already sent out the calendar invite that has the Zoom link on there for us to do some work and hopefully, if I can figure it out, do some breakout groups so that y'all can work together on some problems. So make sure that you attend that so that you can get the best review that you can for the AP exam. So here's the first problem that we're going to review for Unit 4's review. Let the random variable x represent the number of telephone lines in use by the Technical Support Center of a software manufacturer at noon each day. The probability distribution of x is shown in the table below. So because each of these x values have a different probability, in order to calculate the average or the expected value, you actually have to use a different equation. You can't just add them all up and divide by however many numbers there are, just like what we did before. You can only do that when there is when there's equal probability. So in order for us to do this, there's an equation that you can use. So mu of x, which is also equal to saying E of x, is equal to the summation of x times P of x. So what this is saying is that we're taking each of these x values, multiplying it by its probability, and adding it on to the next one. So this would become 0 times 0.35 plus 1 times 0.2 plus 2 times 0.15 plus 3 times 0.15 plus 4 times 0.10 and plus 5 times 0.05. And if I were to add these all up, the expected value is 0.16. Part 2 says the median of a random variable is defined as any x value such that p is less than or equal to 0.5 and p is greater than or equal to 0.5. This is basically just telling you that it occurs at the 50% mark. For the probability distribution shown in the table above, determine the median of x. So if we want to think about median always occurs in the middle, right, at the 50% mark. If I were to create a graph for this probability table, so let's say this is my graph. Here's 0, 1, 2, 3, 4, and 5. 0 has a 0.35 chance of happening. Here's 1, 2, 3, 4, and 5. We know that the median occurs in the middle. It occurs at the 50% mark of the entire data, right? It's 50% it's in the middle of the data. Well, if I were to add these numbers up, 50% happens right here. It's in between 0 and 1. So whenever the median is between a number, because we're adding up the probability, you always take the higher number. So the median of x is 1. In a sentence or two, comment on the relationship between the mean and median relative to the shape of this distribution. Well, if we look at the shape, this is a skewed right graph, okay? For a skewed right graph, the highest point is always your mode. The median is always in the middle. So in our case, the median is at 1, so it would be right here. And the expected value, the mean, is always after. So because this graph is skewed right, so since the graph is skewed right, looking at our values, the median occurs at 1, the mean occurs at 1.6, so the mean is greater than the median. All right. We're going to go ahead and move on to number 2 now. On a physical fitness middle school test, boys are awarded 1 point for each push-up they can do and a point for each sit-up. National results show that boys average 18 push-ups with a standard deviation of 4 push-ups and 34 sit-ups with a standard deviation of 11. What is the standard deviation of their combined score? So what it's asking you to find is, what is the standard deviation of the push-ups and the sit-ups? And the equation for this is the square root of sigma p squared plus sigma s squared, where p is the push-ups and s is the sit-ups. So reading the problem, the push-ups had a standard deviation of 4 and the sit-ups had a standard deviation of 11. So if I put this into the equation, I have 4 squared plus 11 squared. And if I put this in a calculator and do my math, I get 11.7. All right, we're going to go ahead and do the last problem. Number 3. A company that manufactures smartphones developed a new battery that has a longer lifespan than that of a traditional battery. From the date of purchase of a smartphone, the distribution of the lifespan of the new battery is approximately normal, with a mean 30 months and a standard deviation of 8 months. For the price of $50, the company offers a 2-year warranty on a new battery for customers who purchase a smartphone. The warranty guarantees that the smartphone will be replaced at no cost if the battery no longer works within 24 months from the date of purchase. So some key things is that within means that we're at less than or equal to 24 months, okay? In how many months from the date of purchase is it expected that 25% of the batteries will no longer work? Justify your answer. The hint that I'm giving you here is that 25% is associated with what z-score? The equation that we're going to use is the expected value, which is our mean, plus the standard deviation times the z-score. And the reason why we're doing this is because z equals x minus mu over sigma. Okay, we're trying to solve for x. Well, we know that the p-value is equal to 25%. And a p-value that's equal to 25% is z equals negative 0.6745. And how do we do that? Well, there's 2 ways that you can do this. We can use the table. So let me see if I can find our z-score table. So if we're looking at the z-score table, we're looking for a probability of 0.25. Well, 0.25 is less than 50%, so we're going to look on the negative side. And the value that's closest to that is right here. So that is negative 6.7. Negative 0.67. What's the other way that we can find the z value without using the table? Well, if you have your calculator, you can also do that. So I'm going to pull up the calculator. If we have our calculator, we can go to second, hit vars to get our distribution, and we would go inverse norm. So remember that inverse norm gives us the z-score associated with the p-value. So in our case, the p-value is 0.25. Our mu and standard deviation is always 1, or 0 and 1. And the tail is left because we're trying to shade to the left. And this gives us a z-score of 0.6744. And I rounded to 0.6745. So we know that our z-score is negative 0.6745. We have mu, we have sigma, and we're trying to solve for x. So I'm going to rearrange the equation. We're going to do x equals mu plus z times sigma. So then x equals 30 plus z, and z is negative 0.6745 times 8, and we get 24.6 months. So what this is saying is that we expect 25% of the phone's batteries to stop working at 24.6 months. Okay. Suppose one customer who purchased the warranty is selected at random. What is the probability that the customer will require a replacement within 24 months from the date of purchase before the battery no longer works? So here we're going to be calculating a z-score to use to find our probability. So z equals x bar minus mu over sigma is equal to 24 minus 30 over 8, which is negative 0.75. Now, if I go back to my chart, I'm going to look for negative 0.75. So that's here. And our probability is 0.226. So P equals 0.2266. Okay. And we know that it's this one because we wanted the battery to be replaced within 24 months. So if this is 30, 24 months would be here, and we're shading to the left. So we just pull that probability from that table. So P of x less than or equal to 24 is equal to 0.2266. The company has a gain of $50 for each customer who purchased a warranty but does not require a replacement. The company has a loss, a negative gain of $150 for each customer who purchased a warranty and does require a replacement. What is the expected value of the gain for the company for each warranty purchase? Well, remember that this warranty only occurs for 2 years, right? So what that means is that the probability of x being greater than 24 results in a gain, right? Plus the probability that someone does replace the battery times the loss to get our expected value. So in this case, we have the probability that someone does have a battery that doesn't work in 24 months is 0.2266 times the negative 150. If this is the probability that someone does have a battery that stops working after 24 months, then the probability that someone doesn't have a battery that stops working is 1 minus 0.2266 times the $50. And if I were to put this into my calculator, I would get $4.68. So the company is expected to gain $4.68 for each warranty that they buy or that is sold. That's it for today's review problem. Make sure that you come to office hours on Tuesday and Thursday from 2:30 to 3 to ask me any review question problems that you may have. This is the best way for you to get help and get your studying in. I hope you all have a good day. See y'all soon.